All right, so I want to go ahead and welcome you to the computer graphics and animation course. Let me just sync up this GitHub repository. I'm trying a lot of new things this semester. Okay, one of them is using Git to kind of put all of the lectures and everything on. Open. Okay, so I guess we got more people in this class than the rendering class, so I guess physical simulation seems to be a little bit more popular, but I also think we also had a lot of people in the rendering class last year, so that's probably part of it. So there's basically there's two different syllabi. There's one for grad students and one for undergrad students, and I guess if I can get a show of hands, who is not registered for the course? Okay, so I think everybody's registered for the course because there's a prerequisite override I have to put in because it wants 381, which there's no prerequisite, no graphics prerequisite for this course. We're gonna cover everything that we need up front. Okay. Secondly, okay, who is a graduate student in this course? So we got 4 grad students this course, okay? Because there's a different syllabi for grad students versus undergrads, and then so it looks like we're split about halfway, okay? The biggest thing here is that grad students have a lot more work to do besides just make a more advanced version of this project, okay? So we're going to open up the grad version of the syllabi, and then I'll note any changes for if you're just a regular undergrad student. So let me go ahead and make sure that everything looks good over here. Okay. Okay, so I think we're good over here. Okay, so the only prerequisites for this course is basically if you've had physics along, just because I can't teach physics. It helps if you know a little bit about physics kind of going into this. So obviously our meeting time is here on Tuesdays from 11:30 to 1 p.m. right in the middle of lunchtime. So either pack a lunch or or eat afterwards. I don't really mind either way. This is a hybrid class. Namely, what that means is that we're going to meet Tuesdays in here, and then on Thursdays we have a special topic that I'm using a technique on screencasting. So I'll basically prepare like a micro lecture, essentially on YouTube, and so you guys watch the micro lecture, take notes on it, and then you'll have an activity to do along with it to kind of help you out as far as homework goes and just understanding the material. It's a really effective way of doing it because when you're learning, I don't know the exact percentages, but essentially, you retain a certain amount of information if you hear it, a certain amount of information if you read it, a certain amount of information if you actually do it. And by far, the best way to learn this kind of material is actually by doing it. So that's kind of, I think, going to help us out. Plus, maybe it won't seem like as much work because it takes a lot of effort, I guess, to make your way through a certain class and certain preparation for that. So there is no required reading for the course in terms of like a textbook. However, I'm going to use this one, and I recommend this particular book if you really want to follow along with the course and kind of see all the math and stuff. Okay, so I'll make sure that you guys have everything. If you guys feel like you're lacking anything, just let me know. That way, I have the advantage of having the book, and you guys don't. But yes.
Do you know if the library has a copy?
I doubt it. I doubt it. This is when did this book get published? Actually, the library copies can be very expensive. This is 2017. I'm pretty sure the library does not have a copy of this book. Last time I asked for a book, they quoted me hundreds of dollars for a book that was like 50, and I was like, it seems a bit expensive, especially if I'm just kind of like testing the waters with something, and it takes a while for the library to kind of sync up with that. So no, the library does not have this book. It could. It's possible, but I didn't look. Okay, I don't think it does. The book is not that expensive, though. In fact, we could take a look.
Kindle version on Amazon, 45.
Yeah.
Somewhere in there.
I don't know if it's worth it to get the Kindle version or not. You can. The only reason I would say don't get that versus the hardcover book is that math equations and the Kindle, that doesn't mean, getting the formatting right on a Kindle book is very difficult. Okay, so if you get the Kindle book, it could be that they've converted everything to images and the flow isn't right, or sorry, let me get a drink here. I just find with math books it's hard. It's great for novels. English classes are probably just fine, but you probably want to get the book. Okay. Otherwise, you can just look all this stuff up. A lot of this information is out there. I find myself, even when I'm researching stuff for class, I'm just searching. There's so much stuff on Wikipedia, for one. Like physics, right? If you're just trying to learn how gravity works, you don't need a $60 textbook to tell you how gravity works. It's going to be out there very easily. And then the other part of the book that is kind of intangible is, like, there's going to be like advanced things in here, like say fourth order Runge-Kutta. I don't know that I'm going to talk to you about fourth order Runge-Kutta, which you can look up anyways, but the point is that when we're talking about physically based simulation, there's a limit to what you guys can be reasonably expected to do on your own, so we'll prefer the simpler methods, right? The things that are easier to code, rather than focusing too much on trying to optimize math things for a particular kind of simulation method. Okay, there's another book which it's in my office, but it's more on fluid simulation, and the big thing is that because this is a research-oriented class, I really would like you guys to search for papers and stuff that talk about the methods, because that'll be good for you to be familiar with that. This is a good book in terms of, like, having a good bibliography, so you can kind of get an idea of what the state of the art is, which is what we're trying to focus on. So this is the book that I recommend, just because it covers lots of different topics. If you were wanting to focus on maybe one particular topic, like fluids or something, there might be some good recommendations for those particular things that maybe this book would touch on, but then not get into like the right kind of detail for you. Okay, so that's the book, Foundations of Physically Based Modeling and Animation. I think it's a great book to be a good resource if you really want to jump in on this. Okay, so when it comes to like physically based simulation, I find it's a topic it's very mysterious. You're like, I would like to do it, but aside from when you're getting into physics at first, you spend a lot of time talking about mechanics and stuff, and then it starts getting advanced pretty quickly, right? Like you want to, you say you're working on like bridges or something, and you're like calculating the individual. I know when I was taking my physics classes, I was always thinking about oh, that would be so much fun to like write a simulator for, to calculate what the stresses ought to be for a bridge. But then, the physics class is moving along so fast, you're like, oh, that would be cool to do too, and then you just never get to it. And then by the time you do get to it, or you'd like to do some of the more advanced stuff, like 3D fluids, then you're like, okay, but that's stuff I want to work on, right? So then you go look on YouTube, and you're like, I need to learn about the Navier-Stokes equations. And then at that point, it's like you come to a grinding halt because no physics class you've ever had is talking about Navier-Stokes and how that works. And you're like, oh, I'll just have to put that on the top shelf where all the dreams go that never get, And so I imagine that many of you are here because you're like, oh, we can dig that off, dust it off. That dream could still be alive. I might actually be able to simulate galaxies or fluids or all that kind of stuff. Okay, and it's true for me too, because while I've studied a bit, I've been studying the math and stuff behind it. Actually making like actual, and I kind of worked a little bit with like fire and fluids and stuff like that on my own time, because I was trying to simulate the global illumination effects of fire. I found that it'd be really nice to dig into the math, but then it was like a bit too much at that time frame. So anyway, so this class, we're going to really make those kinds of topics approachable, and for you, I'd like your experience to be like a checklist. Like, all right, I did this, I did that, I did this, I did that, and and make those things like things that would normally be impossible, but make them achievable. So that's our goal, is to make these things that seem like they should be impossible be achievable, and that way you can kind of go back on it. So I all have checked off a number of things that you're like, oh, I wish I could have done that, and now we can do that. Okay. Now, since half of you are grad students, it was a little bit different story for the first class. It was everybody but one student was a grad student. So I guess I don't have to say graduate student. I can say students, It's going to be a little bit, I want to make sure that your time is spent on the research aspect of it, in terms of that's primarily what differentiates your workload versus the workload for undergrad students, okay? And so what I want to do initially is talk about what makes the grad student class different from the undergrad student class, okay? So the first one is, as a grad student, as you guys are getting ready to get into doing thesis or project work, you're thinking, or your advisor is telling you, it's got to be new. The idea's got to be novel. It's got to be something brand new that's not been done before, okay? And so I want to make sure that that's one of the key differences between the undergrad work and the grad work. Is it's not that we're just, working on a fluid simulation or working on a gravity simulation. We want to work in a way that how are we presenting this in a new way that's not been done before, okay? So the idea is novelty is a big thing. So, and novelty doesn't necessarily mean this thing has never ever been done before. It could just mean, what way can I take it in a new direction that maybe hasn't been done the exact same way 50,000 times by a bunch of other people, okay? There's lots of ways to make an idea new. A lot of these equations are very old, okay? But every year you manage to go see a brand new movie that uses these physical simulations in a new way that has never been done before, okay? So just because some of the stuff's old doesn't mean we can't make new things out of it. Okay, and then secondly, there's additional homework projects for the grad student versus the undergrad student, and we'll talk about that. So this is what I call a hybrid course, and that means that I mentioned that on Tuesdays we're going to get together and we're going to talk about a lot of these topics, but on Thursdays, this is the rough list of topics that I have picked out. So this Thursday, we're going to have the computer graphics crash course. And so if you've never taken a graphics course, this will just introduce you to all the basic ideas that you need to create graphics applications. And so one of the hardest things to do in computer graphics is just get from having a blank screen to having something, that is showing any kind of information at all. So that's essentially what we want to work through at the very beginning is get a graphics program working so we can actually do experiments, right? It'd be like being a chemist and then you go in the lab and there's no beakers and there's no test tubes, there's nothing for mixing stuff, and you're like, I want to get to the chemicals, but you have to build the experimental apparatus first. Okay, so that's what we're going to do. So the rough schedule is that next week we're going to really get into models, simulations. So how do we actually create create a simulation on a computer? And so this first week we're going to spend time getting graphics. Next week we're going to start on let's actually simulate something. Okay, and then we're going to talk about bouncing balls the following week, because we got to kind of we're going to work our way into particle systems. So now in this class, how many people have a computer that's at least 1 gigahertz? Okay, that should be everybody. Okay, because sometimes when you do graphic stuff, the first time you get stuff off the ground, you have things that are measured in tens or rarely hundreds, right? But we all have these fascinating computers that can do 1 billion things a second. I mean, at least. Okay, so when we're doing this simulation stuff, I'd like us to think about, and that's what we're going to spend our time with our graphics thing. Okay, let's see if we can't get 1 million things on the screen, doing something, right? Thousands, millions, because some of this, the reason why this stuff is even interesting is because we're seeing millions of things interacting millions of things interacting with each other, and just seeing the complex behavior happening. Like just for fluids, right? You might have a grid, but we're not interested in a 10 by 10 grid of fire. It seems like it might be boring, unless you're making an 8-bit game, and that might be perfect, right? But our mindset is let's think about, if the default is for I equals 0 to 10, let's try to think for I equals 0 to 1 million. Okay, so we're going to talk about particle systems. Okay, so we're how to get those things to kind of work, and then we're going to talk about things you do with particle systems like acceleration operators, velocity operators. So these are, we'll have all these little particle things, and we'll do functions on them, and like an acceleration operator, that might be gravity, for example. Gravity is an acceleration operator. Then we're going to talk about the difference between Lagrangian and Eulerian simulations, okay? Because they are two different mindsets going into there. A lot of times you combine the approaches, but essentially there's a difference there. So we're basically going to start off with particle systems, and then we're going to move into fluids. Okay, so we're going to do a mathematical background for fluid simulations, talk about Navier-Stokes and how that works. Same thing for the following week. Talk about smooth particle hydrodynamics. And then after that point, the last bit is we're going to move our attention to like rigid bodies. So, and some of that has to do with like springy meshes, so like springs, rotation, collision, cloth physics. I think that'd be fun to see what does it take to do cloth physics. And we might have time at the end to pick some additional topics. But if you have ideas like, hey, it would be nice if we could cover this particular topic, then feel free to send me a note. This is a good time to do it because I haven't really sketched out all the lectures yet, so it's a good time to do it now so I can kind of figure out what you guys might be interested in, okay? The course outcomes, basically we're going to, I have a scene graph library. We're going to do everything in JavaScript or TypeScript, which is a really fast way of just getting graphics off the, just going. Doesn't take very much effort to kind of get into there. In the previous graphics class last semester, we did everything in TypeScript, but I'm trying to make it a little bit more lighter weight. So you guys feel free to use TypeScript because it is a convenient way of doing JavaScript for one, and you can learn something new. But JavaScript, you can basically just open up a text editor and just go from there. Okay, grad students, I'll let you read the syllabus on your own, but you'll notice that for every one of the regular outcomes for everybody, there's like an additional thing for you to think about. Okay, so like, so for instance, we're going to talk about gravitational attractors, but I'd like you guys to think about how are people doing this in the scale of millions or billions nowadays, right? For collision detection, I want you guys to think about, how do you control computational complexity for collisions? Okay, so these are going to be some outcomes that are maybe a little bit more specific for you guys, but they kind of go along with the general understanding. Like we'll talk about visualization of particle systems, right? Everybody likes looking at like weather patterns, right? And you see all those vector fields and seeing how things are behaving. Okay, so these are the course outcomes. The way that the grading and the course policies go, the course policies are at the end, and it's basically there's like a whole bunch of policies that the university has, and so it's like 3 pages worth of stuff to read, but this is all general stuff. So in fact, I make my syllabi with LaTeX, and it's just to input all the policies. It's the same exact thing. So if you're taking another one of my classes, it's the same exact information. Okay, so we're going to have 2 exams. They're both going to be take-home exams, so a midterm and a final, both worth 20%. We'll have a research project, and that's worth 15%. And then the homework assignments will be 40%. And one thing I like to do is I like to take the lowest homework grade, and I'll take the average of the other ones and replace the lowest homework grade with that one. So if you have a bad homework you just can't get working, and it's just you should do them all. Okay, but that is my that's how I handle the homework grades. And generally, if you make improvements to your previous ones, you can always submit those. I'd rather that you guys got the benefit of doing your best work, that way at the end of the course you're like, look at all the cool stuff I did, and so you are always able essentially to revise your stuff. I don't know if I've been convinced yet not to have due dates for everything, so basically late homework gets penalized a whole letter grade every day that is late, and then normally gets a 0 after 3 days. That's just to keep you guys on track mostly. And then we use Slack for online collaboration, so this is like an example of the Slack. So there's it's a UAF Computer Graphics AI, that's the name, and I'll have that out on the main page where we have all our information. But essentially, I want to encourage you guys to, this is like a half online course, right? So I want you guys, there's always that kind of like mandatory online participation. So, but the idea here is that I'd like you guys to use this to kind of talk with each other about, hey, here's something interesting I found, or this channel over here, today you can put, hey, I'm doing this today, so you can broadcast what you're kind of working on. Okay, so we use Slack for online communication, and I have it, so it's a good way to get a hold of me if you're trying to send a message, or you can send it via email. Okay, so 5% of the grade is class participation on Slack. So let's go ahead and talk. Let me talk about the research project first, and then we'll talk about the homeworks. Okay, so the research projects essentially are, so if a grad student, it's 6.5 pages. If you're a undergrad student, it's 4.5 pages. Written in LaTeX. Basically the idea here is let's make it look like it could belong in a journal. I find that the closer you approach things, the way they ought to look in the future, like research, right, being published, then it kind of gives you some motivation to work a little bit harder at it and get you actually some valuable experience. Because if you're preparing a journal to go to SIGGRAPH or i3D or any number, it's helpful to actually have experience writing it in LaTeX, and so that's kind of a thing I like to do in my class. And then for grad students, 8 journal citations, and 3 of them have to be within the last 3 years because we want to be focusing on new research. It's good to have an understanding of all the essential papers, all those important papers, but we want to focus on new research. And then this is kind of important for grad students, but one of the things I'm looking for, especially in that final, why is your project new? Like what makes it new versus something that's been done before, right? So, and this is something that in a journal, right? If you were submitting work, they want to find out. You have to justify why it's new. It shouldn't be up to them like they receiving the paper on their desk and be like, oh, this is new. No, that's your job to tell them why it's new, and then they can decide whether it is or not, right? Because they have the background experience. So a lot of times what this has to do with writing a good thesis statement, which is just like one sentence that basically says what your paper is about, and it's inarguably the thing that is new about your paper, right? So if you're writing a research paper on, or like for example, my dissertation was on global illumination using spherical harmonics in a certain kind of way, right? So my thesis statement basically saying you can use spherical harmonics in this kind of framework to simulate global illumination, and there's no like extra work that I have to do to kind of justify why my idea is new. That is a new idea, and so you can always go back to that and say why it's new. So novelty, that's something I'm looking at, and you can kind of see the point breakdown for everything. Now there's basically 3 presentations to go along with each for the project. So initially there's a 1-minute presentation. It's a pitch, so you're basically going to give 1 minute to explain what you're going to do and what we should expect to see by the end of the semester. And then we'll have a 5-minute presentation in the middle, so you can kind of get up, show what your the progress on your work, and then lastly a 7-minute presentation talking about how things ended up. And I'm actually going to put a timer up here so we can kind of get the experience of being in a refereed session where you really do have this whole conference is running on a schedule, and you have to make sure that everything so I'll have a nice big timer so you can see where you're at, so we can kind of pretend that we're having a conference of our own. Okay, let's see here. So grad students. So this kind of goes along with probably what you're working on, right, for your research project. But basically, there's if you're a grad student, you're going to present the results or method of a research paper in a short presentation, and we'll have one of those every week, and we'll go round robin until you've done at least 2. So this was kind of funny in the last class because we only had one grad student in it. At first, before I mentioned that, it's like, you know, every week, you know, you're going to be doing a 5-minute presentation on something brand new every week. So I limit it up to 2. So we have 4 in this class right now. So we should be able to 5. But that's so you guys should be able to present 2 times. So that'll be a fun way of, you know, you can use whatever you're doing your own research on, as you know, as long as it's related to sorry, as long as it's related to the simulation animation class. So we'll go ahead and get that schedule set up next week, so we can kind of go ahead and get that rolling. And then let's go ahead and take a look at, we're going to talk about homeworks, but let's look at the schedule real quick so we can kind of get an idea of when all this stuff is due. So you'll see that in the 3rd week is when we'll do our project pitches. So that Tuesday, everybody will come in to start go over what we're going to do. So there's 6 homework assignments if you're a grad student. There's 4 that are required by everybody. Well, 4.5. Okay. And so the idea is that 2 of those homeworks are going to be due before the midterm, plus whatever your additional one is, and then 2 will be due before the final. And so you'll see I have I'm still thinking about the schedule, but you can see kind of more or less when I'm expecting all this stuff to be done. We're gonna do another game competition like we did in the previous class, but it'll be joint between the computer graphics rendering class and this particular class. So some people will have to make 2 games. But yeah, I always find that it's a fun way to end the semester. Game competition plus it's very rare that you get a class where you have to make a video game. So we'll do that. So okay, let's look at the homework assignments. Okay, so the required homework assignments are, we're going to do real-time rendering of thousands of objects. Okay, so that's kind of getting your feet off the ground. Then we're going to have gravitational attractors, so we'll write a particle simulation where the idea here is, like, you know, simulate a galaxy if you want. Okay, and then we'll get into the fluid, so Navier-Stokes fluid simulation, and then a rigid body simulation at the end, so we kind of get experience with those concepts. And then so grad students, you'll pick 2 out of the following. Okay, so it could be a video documentary, so maybe you want to talk about a simulation technique. You can make a video, YouTube video. You could create debug tools, so you could talk, maybe put it in context of a simulation, you know, maybe you need a debug tool for changing the setup of a simulation or something. It could be a video game based on our proof theme. Lots of video games have physics as like their main game mechanic. Cloth physics simulator, that could be, if that's up your, that's on the list of homework assignments, or a 3D animated short film. So I don't want to just limit it to only pure physical simulation. So if you actually wanted to spend some time working on like a film, you can do that. And then we'll all finish up by doing the game competition towards the end. Now, the workload on the assignments. The first one is probably more involved than I feel the other ones are, just because you are probably working on getting graphics running from scratch, and you have never done that before, or just, I mean, just even if you touch the code from last semester, it's probably already broken. That's just how, you know, for some reason the laws of entropy apply more so to dormant code than the universe. That's my theory. You just have to wait 2 years for new compilers to come out, then your old stuff doesn't compile anymore. You know, it's just how it goes. Okay, so so that's kind of the, I guess, lay of the land for the course. This schedule more or less mirrors the list of topics that we're going to cover. Let's see here. the idea is that spring break, you don't really have anything due. After the spring break, we'll come back. We'll do our, well, the midterm will be due after spring break. But my idea about spring break is not to load you up with a bunch of stuff so you can't, take a break, right? So that's where we are there. Okay, let me think here. Any questions so far? Okay, so here's what I'm looking for homework. I kind of explain what I'm looking for the research paper, in terms of, what is that? Length and, having the basic format of a research paper, like an introduction, previous work, all that. So here's what I'm looking for homework grades, okay? So these are all pass-fail. In other words, if your program doesn't run, I'm not going to give you a grade, right? That's if your program doesn't have the source code and the screenshot, we can't grade it. The project page should include a description. In other words, like explain what your project is doing. And then here's the things that I'm going to assign a score on. So it's a little bit different for grad students versus undergrads, but the difference is interaction and novelty. Okay, so here's what I'm looking for. Interaction. We don't want to just do demos where the user doesn't do anything, right? It'd be like playing a game but then not having controls. It's like you can watch somebody play a game. That could be fun, right? But we want to spend some time working on the interaction. So we're going to make graphics applications that you can work with. So I'm going to grade. So undergrads will be 200 points, or approximately, what, 40% of the grade is what can you do to interact with the program. Secondly is correctness. So for example, like if we were like simulating Phong shading and I saw toon rendering, obviously that's not correct. So we want to focus on correctness. So, or if you're simulating gravity on Earth and all of a sudden objects start flying up, like you got your gravitational constant sign wrong, that's not correct. Okay, so correctness at 200 points, so 40%'s, how correct is your program. And then for grad students, novelty, right? So is what I'm looking at new, or is it just the same kind of demo I can find all over the place, So, yeah, so anyways, pretty simple. Obviously, there's a certain amount of subjectiveness to this, right? So basically, if you can answer these 3 questions, can you interact, can you control the application in a meaningful way? Can you do you correctly implement the technique or algorithm? And is this a new idea? That you will have no problem getting full points on this. And my expectation for homework isn't that you're going to spend all weekend working on a homework project. It's more like that you could handle this kind of thing in 4 or 5 hours, right, start to finish, And so, I mean, it's not going to be, it's difficult to make graphics applications in a few minutes. Now, if you're really practiced, you can, but it's hard to make a well-polished graphics application in just a few minutes. But at the same time, it's like art, you're never really finished. You just have to kind of, at some point, you're like, okay, we're done. Send it out the door. It's shipping, right? We'll do the bug fixes later. Okay, so any questions on the research project or how the homework works? Is it too much work? Does it seem like too little work?
Having to be novel regularly terrifies me, but okay. Let's try it.
It's, well, I want it to be terrifying, right? Yeah, I'm not asking, and like I said, so here's a great way how to make a project not novel, okay? Let's just look. I'm just going to search images, okay? A lot of stuff looks pretty good, doesn't it? Right? This I would say is probably novel, right? If you make something like this, is like, hey, that's pretty good. Now this could also be like somebody's like PhD dissertation, you know, and then that's obviously not going to work in 4 to 5 hours. But let's look at something, I don't know. How about we look at boring graphics? Literally, yeah. If this gets turned in, you know, boring, maybe boring graphic design, right?
Simulation or something.
Or yeah. It's even worse. Nap simulator. This is novel, right? I mean, that could be interesting. Oh, bad graphic design. Let's look at bad graphic design. That's boring. I mean, that is not. I mean, this is easy to do, right? And you could just create a rainbow, right? Or even some of this stuff is this. I mean, that's. I feel like there's plenty of graphics out there that look like that, right? That it's like, okay, this is nothing to look at. Okay. Maybe we could look at simulation software. This is probably a good way of making something look boring. Sure. That doesn't look novel, right? I mean, it just looks like I visualized using just some charts. You know, you probably could have come up with an interesting way of like doing this. Okay, that isn't like boring. And maybe that's my way of saying don't turn in boring stuff. Or like over here. Here's another good example, right? This is not novel. Okay, the simulation might be, but this visualization is not novel. You know, there are fun ways to spice that up so that it you know, it looks cool. And maybe partially is like it's got a bad user interface, or you know. But the thing is that even this, I guess, I mean, this could be novel, potentially, like if the shark's jumping out of the water and it looks fun. But I guess the big thing is, you know, if you're working in the real world and you're asked to create something and it's for public consumption, right? How many people have been to boring museum exhibits? Okay, and how many have been to great museum exhibits, where maybe the difference in how it was presented made the difference? Okay, and so that's partially. It's easy to make bad graphics. I guess that's what I'm trying to say. It's easy to make something bad, but there are. Sometimes it's just the colors you pick could make it look like night and day, right? Sometimes it's just the polish on the program that makes it feel like, oh, this is something new, okay? If it's, I mean, yeah, and like I said, this is probably, maybe it's the model that you pick, right? I mean, if you're just turning a bunch of spheres and cylinders and you're showing a heat map, maybe that's not boring, but maybe if you do it on something different, like a dinosaur, or, you know, if you show something, right? And a lot of times with computer graphics, you know, as much as it is like math, right? It's like, how can you make math look interesting to your mom, right? You know, and so that's kind of what I'm going for. I mean, that could be novel. So, anyways, the idea is, let's not turn in stuff that has got the bare minimum done to it, because chances are the bare minimum is boring. But if there's a fun way to interact with it, or you know, or it could be that, you know, normally, like on, say, the airplane, so, well, and this is your chance in your description to talk about why it's new, right? So maybe you say, oh, there's lots of visualizations in airplanes, but this is how ours is different. We wanted to focus on this element on it, right? And in a way, this is like a method of communication to people, okay? So we're just looking for something clear, and that's the main idea there. So let me go back. Okay, so I don't want you to freak out too much about novelty, but I do want you to like think about, is what I'm making like something new? Okay. Like I said, these are old equations, but I promise you, every year you will see a brand new way. Somebody will come up with a brand new way of blowing a mountain up, or making water fill a city or something that will make you shell out money to go see it. Okay, and so we're not looking for something that's obviously I don't expect you guys to create Cars 2 or something like that in a weekend, but we also don't want to make just Cars 1. Yes. Actually, it was kind of funny. I really liked the new Incredibles movie that came out, and because the first one was pretty amazing. One thing I didn't realize with the limitations of the software, that when they made the first Incredibles movie, they could only have 6 characters on the screen at one time. I think that was the max that their software could handle. You would never think it watching the original movie. But when you watch the new movie, because they basically redo the end sequence, but done in a new way, you can see all the ways that they made the old movie just pale in comparison. Okay, so if you haven't watched the new Incredibles movie, lots of great physical simulation used in that movie. And just the first 5-10 minutes of it, just worth watching, just to see how much of an improvement they made over the last one. Now, the only downside to the new Incredibles movie is that when I went to SIGGRAPH last year, the production team was presenting all the stuff, which was kind of fun to watch them. But they almost seemed relieved it was over. Which means, and part of it was their time to work on the project was, they were trying new ways of getting this movie out the door, so they didn't have a long time to work on it. But you could tell that they were worn out, which was funny because a few years ago I went and saw the people that made the movie Brave, and it was a completely different atmosphere. You could tell that they almost didn't want the project to end. They had so much fun with it. So we don't want a project like that where it's like, I'm dreading it. Dr. Mezger wants his novelty stuff, and it's just but really all that means is let's just try to find an interesting way to. It's how interesting is this, right? And I think you all are good judge of what's interesting, unless I see your taste in movies is terrible, and then I'll be like, but my taste in movies is terrible, so chances are you'll probably be like, oh yeah, this is fun. Here's a good, maybe I'll just brag on the previous class. Let's see if I can go back to the, I'm gonna brag on the previous class. So we were doing 2D graphics, and everybody, really the homework was just asking for, I think we had to make a game or something like that, but the basic idea is okay, we just use color, typography, sprites, tile graphics, and stuff, and I got all this incredible variety, right? And everything is, you can click on just about everything, and except maybe that one. That one's probably boring. But generally, there's something interesting to look at each one. They're all novel, That's it's something new, Even if it's a twist on an older concept, there's new ways of doing it. So that's kind of what I'm talking about. It's just, oh, okay, let's do it in a new way. Okay. Let's see here. Okay, so let's go back to the every year I keep saying I'm going to make the syllabus presentation interesting, and I always find that it's kind of a snoozer. One of these days, I've always contemplated, what if I just don't talk about the syllabus until the following week and just kind of jump into it? It didn't happen. Anyway, okay, so I think that's all there is in the syllabus. So now, the big thing about this class is I'm trying out new things. I think I mentioned in the previous class, it's technically the third class we've ever taught. This is now my fourth class I've ever taught. So I'm always looking for feedback. So if you guys ever have questions or like, or comments, or if you have any things like, I know you went over this example in class, but it was the most boring thing I sat through. Thank you for letting me catch up on nap time. Or like I said, I really am interested in feedback. I want this to be. I find that a class is going to go the smoothest if everybody's like on board, excited about the material being covered. So if you have any, just let me know. And it's I'm a pretty easygoing guy. Okay, so let's go ahead and start talking about where everything is going to be located. So this is either going to be like my undoing, or it's going to be brilliant. I'm dreading it, actually. So we're going to have a we're going to have a GitHub page, and I'm going to basically put everything on the GitHub page. Let me go back here. As far as the main list, here it is. Okay, so I'm going to be putting everything on the GitHub page. So basically the idea is that if you want to get the slide notes or anything like that, you can just do a git pull and you'll get everything. And then what we're going to do is we're going to try out a WordPress site. And the WordPress site will basically be like a nice way of formatting everything. So this is the other one. Basically, I'm in this course called Epic, and it's basically a course to teach instructors how to create interesting online courses. So I'm doing that for the other one, but I thought I would try to copy some stuff with this particular one. So I forgot what I called it. Oh, here we go. Okay, so this one's going to be cgsimulations.community.uaf.edu, and the idea here is that all the descriptions for the homework assignments will be here. The syllabus will be posted here. All the YouTube links so if you need to go back and rewatch a lecture, that'll be in there. So this will basically be like the front page of our site, and so this is one element of the whole thing. See in the README here, if you need information about me, there's my homepage on the UAF website. So if you need to find out what the office hours are, look at all the other courses I'm teaching, or whatever, it's all on here. And then we're going to do a similar homework site like we did with the previous class. So, which means that you guys will submit your homework via Blackboard, just because it's easy for me to grade with Blackboard, and then you guys can see all your grades. So that'll be, Blackboard will be where you submit your homeworks. So I still have to set that up, but I'll send out a mass email. But basically GitHub's, I'm going to try putting everything out there, and hopefully this will be an interesting way. I find myself with too many computers right now. I have a MacBook I'm doing some projects on. I have my Windows PC I'm doing things on. I have a Unix system I'm trying to get up and running. So there's too much. I think there is such a thing as having too many computers. I think it's becoming an illness. So anyways, resources. I do have a number of NVIDIA Jetson TX2 boards that I'm setting up right now. And so if you want to try out your software on an ARM-based system, a 64-bit ARM-based system with an NVIDIA GPU built into it. So if you're running they're all running Ubuntu, but as soon as I get it set up in the next couple of weeks, I'll probably have, and you want to try out using those things for doing benchmarks or whatever, feel free to. And then what else? We're going to do everything in JavaScript. I think I maybe mentioned that. The earlier class, we were debating the fate of this class. We were talking about, should we do C++? Should we do JavaScript? Should we do Python? But I think overall it's faster to write software in JavaScript and get it up and running and share it with other people than it is with the other ones. So we're gonna go with that. Let's see here. I feel like this class is probably the least prepared when it comes to getting graphics up and going. So we're going to switch gears and use the last half an hour to kind of talk about how to set up a graphics application. And then some of this information will be a little bit repeated with the content on Thursday. But I think if we wanted to, we'd take a 2-minute break, stretch, yawn, something like that.
So your library thing is all set up in TypeScript. Are we going to need to recreate something like that in JavaScript?
So what I think I'm going to do is I'm just going to compile everything, and then you can just include a JavaScript library before your JavaScript code. Or you could just use the same framework as before and just write everything in TypeScript and then have it export like before.
Will you be going over it, I guess, a lot in class? I mean, so like if I'm holding fast to TypeScript, will I be kind of lost if you're working on like a new JavaScript version? Okay.
No, because I'm writing everything in TypeScript in the background.
Gotcha.
I just don't want to force everybody to have to use TypeScript. So I'm trying something new this semester. I'll see if I like it or not.
Advantages, disadvantages, TypeScript?
That's a good question. I guess ones that I like TypeScript because it's more organized. Or, I mean, it just has strong typing, right? Is that, I mean, it's
right.
The main,
yeah. It's a superscript. Is that the right, or superset of JavaScript?
To say that it is, or JavaScript compiles as TypeScript.
Yes. Yeah. The biggest thing is that with JavaScript, everything's an object. Whether it's an integer, true, false, an array, it's all an object. So behind the scenes, if you almost think of everything as a pointer, then that's what it is. So if you say something is a number, then really the variable you're working with is a pointer to that number in memory. So what ends up happening is you can, as you're writing your JavaScript library and you have no type information in there, you're like, well, do I pass a string to this function, or do I pass an integer to this function, or do I pass an object to this function? Where what TypeScript does is allow you to add those annotations in there that says this function, this variable is a string, or this variable is a number. And so it'll catch a lot of those errors for you up front. So it's really nice. And so all you have to do is you install a compiler, and it basically turns TypeScript into JavaScript. Okay. The only confusing part of the whole deal is that it relies on Node.js, which is more of a I guess a back-end type thing, and so the only downside is that you have this like concept of modules that I personally think is completely messed up. So much so that it's very confusing to write something that you're thinking using modules like it's going to act like everything is going to just magically work if you just include all the right stuff. It's just, you know, like Python, right? If you import a module in Python, you know, it's just because you have the file in the local directory. There's no special thing going on. Whereas with JavaScript, everything's asynchronous. So you're loading up JavaScript in the background, but you don't know if you have this object available or not. So you don't know if your library is loaded in memory or not. So the module system is working on this fact that everything's asynchronous. And so you can't just sit down and write a program with a module system without everything being without using a special library or using special syntax for it. That's the only downside to it. Now, the one thing I really liked about TypeScript is you have a bunch of TypeScript files, and if you put these comments at the top, they basically say this file depends on a class from this other file, right? And you add these annotations. The TypeScript compiler will take all that TypeScript and convert everything into one single JavaScript file that you can then include in your HTML and then just run it, which is really, really nice. If you use the modules, it turns into a giant nightmare because the workflow for a module system is you have other things that basically take it, resolve all the differences, and then you basically compiles it into one JavaScript, you webpack it, compress it, and you know, make it ready to be sent out, you know, for your users. But if unlike the regular JavaScript concept where you just start typing and then, you know, voila, I got stuff working in the browser. That's the only downside to the whole thing, is the way that the module system works. And it's getting better, but it's not perfect. So I just don't know if I have enough time to really talk about how to use the whole. I'm working on a tutorial basically to do it. So that'll be part of the I guess getting everybody up to speed. But I think for these two classes, you know, since we're not talking so much about how do we make a vector class and how do we make a matrix class, and that I don't really need to go into all that detail there. Okay. All right, so we have 25 minutes, and let's go ahead and talk about I guess, how do we get a basic graphics program working in JavaScript, and introduce you guys to Visual Studio Code, which I recommend. It runs on Mac, Linux, and Windows, and has a very, it's like made for web development. I mean, so if you don't use it, I recommend, but you don't need to use it. So let's see here. Okay, so right here I have my Visual Studio Code. So in order to, sorry, in order to get to it, you can just go to code.visualstudio.com, and you can download. They have like two versions. One's in Insiders Edition, one's the regular one. So if you want to be on the bleeding edge of development and get all the latest features, the Insiders Edition tends to be pretty stable. Or you can just get the regular editor. And the next thing that we will want to do, and I'll start writing some of these notes here in the README as well. Okay. And one nice thing about it is that you can basically have you can do Markdown. Anybody familiar with using Markdown for editing stuff? A few people. What's nice about Markdown is it's a text file format that works. Let's see here. Preview Where is it? There we go. This is kind of nice. So I want to move this over. Okay. So the idea here is, if you're you know, it basically makes HTML automatically for you. But we're going to write the notes, because we can just go ahead and put the notes straight up on the GitHub, and then you guys have access to this. Okay, so step number 1 is we use Visual Studio Code, and we can go to the link there. Also makes it good for typing like code. So if you have, like, let's say Python code, that's kind of nice. So Markdown's really nice for just kind of putting documents together, which is why I'm enjoying it. Okay, so the first one is Visual Studio Code. The second one that I recommend is use Node.js. And Node.js is, we'll go over here, is basically Chrome's JavaScript engine. And so basically, if you want to write server apps or anything, you can use Node.js. So you can just download the latest version and install it. And what I like about it is we can go ahead and install I'll just go ahead and teach you guys how to use TypeScript. But the big thing is we want to go ahead and install some linters. So web development tools with NPM, which is the Node package manager. Okay, so the idea here is that at the command line, maybe I'll just put a bash shell thing there. NPM install. So TypeScript, ESLint, TSLint, Byte server, and this other library called concurrently. Now, if you're installing Node on a Linux system, you do not want to use your package manager. It's a default Node installation. It will not work. It's an older version of Node. What you want to do, and I guess I should put a note here. They actually do have, so like, let's say you want to find like the Ubuntu version. And they basically have everything here. Okay, so we'll just go with where'd it go? Debian. Oh, okay. So node source. All right. So node source is a where is the instructions? So the idea here is that you'll download the setup script, and it'll just install the package, the correct package source for this, and then you can go ahead and install Node.js. All right, and this is the better way to do it. Okay. Otherwise, you get an older version that doesn't work right. Okay, so this is one of those things, save you an hour of debugging time. You're like, why doesn't this stuff work out of the box on Linux? And that's just part of the reason why. Okay, so yeah, just be in mind if you're doing it on Linux, there's another place to get it. Okay, so we want to install these tools. All right, so I'll just write what this are. So TypeScript is a compiler, and this is if you're going to use TypeScript, but you don't have to. ESLint and TSLint provide warnings and fixes. So I'll show you what that looks like in this program here. LightServer is a nice handy tool for just running a little HTTP server in the current directory, and then you can just kill it when you're finished, and it'll monitor changes in your files. So if you're actively editing that web page, then you can just go ahead and it'll load it up. if you recompile, it'll recompile everything for you, and it's a nice way of doing it. And then concurrently, is basically you can have several tasks running at the same time. So what I like to use concurrently for is you can start up the TypeScript compiler and the LightServer in one step, and I'll run both of them in the background. I think in the previous class I basically taught you how to run them separately in a separate terminal, but this one's kind of nice because you can you basically just do npm start in your terminal, and it does everything. Okay, so this is the idea here. Okay, now let's see how to. Any questions so far? So these are some steps that you'll just have to do. Okay, so let's think about how to create a graphics project. So I'm going to go ahead and create a new directory here, and we're just going to call it simple graphics example. I'm probably going to redo this later, but like I said, most of my work is on the other laptop, and so I'm kind of creating everything from scratch on this MacBook. So here's what we're going to do. We're go ahead and create a new file, and we'll call this index.html. What's kind of nice about using TypeScript is, VS Code is the web stuff practically programs itself, and so that's kind of one nice thing about doing this. Okay, and so the idea here is that we're going to create a canvas. And how many people are familiar with a HTML canvas? Okay, a few people, but not everybody. Okay, so here is where we're going to just go ahead and create a script. And so we can say let canvas equals document dot create element, and we want to create a canvas. This is the same exact thing as doing this. Okay, so when we call that create element function, it's the same thing as creating the tags. Okay, and then what we need to do is we need to append it to the body. So we'll take the body and we'll append this canvas, and then we can go ahead and set the size. So we can say that the canvas width, say, is 640, and the canvas height equals 480. Use a classic graphics mode resolution for no reason at all, then just because we can. And then what we need to do is create an OpenGL context. Okay, so we can say let GL equals canvas.getContext. And we want, you'll see that there's 3 options here: 2D, experimental WebGL, and WebGL. We want WebGL. Now, I should say that half the reason why all this stuff is working, I guess what I didn't mention, is the plugins. Okay? So, the plugins, I guess, we'll add a section here. Set up Visual Studio Code for web development. Okay, so the first one is actually we can do these ones. TSLint. It'll actually try and guess which things that you should do, so you can just we want TSLint and ESLint. These will actually start, and this is why you have to install Node, because it'll tell you make sure you install these tools in the background. And this -G option just says to install it as a global install. Okay. What else? That's basically it. So what this will do is, if we're doing stuff that's not so great, oh, we got to reload. So let's reload. And there's ways of like installing debuggers, so you can debug your Chrome stuff. If we do something not quite right, it'll basically tell us. Okay, so anyways, those 2 tools are good to have. Okay, so we're creating our graphics in, and what we want to do is we're creating a WebGL context, and now we can actually start sending OpenGL commands. So we can say GL dot, let's just start the first thing. Let's just go ahead and set a clear color. So maybe we want to make it red. So you'll see that we're getting red, green, blue, and the alpha, which is 1. And we can go ahead and clear. And we want to clear the color buffer. And we want to clear the depth buffer. Okay. And so now our program is written, and now we would like to go ahead and run it. Let me move this over here so we can see the code in the YouTube video. So now we want to run it. Okay, so we can open up a terminal, and since I don't have a node project created, I can just run LightServer at the command line. It doesn't like it. Why not? Oh, Control-C. Let's break. We forgot to go into our folder here. Right? Okay. So if we run LightServer, then you'll see that there's our HTML page, and we created a simple context, and we just set the clear color to red. All right. So this is one of the reasons why I like JavaScript, because you can just get your graphic stuff up running real quickly. One really good resource to have is, let me close that real quick. Let's see here. Instead of having that, good graphics links is the WebGL quick reference. And this is like a reference card. You'll see there's 2 versions of WebGL out there. One's 1.0, one's 2.0. However, 1.0 is the one that's basically supported everywhere, and 2.0 is still a little bit being adopted. It'll probably run on your desktop in Chrome or Firefox, but it won't in Edge. It won't run. You can't run 2.0 yet. I'm sure that's only a matter of time because they're switching edges rendering off to the Chromium project. So we're just going to use WebGL 1.0 because it works everywhere. Works on your phone, works on a Raspberry Pi, it works everywhere. All right. And so there's a quick reference card from the Khronos group, and the Khronos group is the folks who basically maintain the specifications. And this has all the objects. In fact, you can see over here that all we basically did was recreate this little project here. And this has, you know, if you want to see what all the functions are, then this will tell you what they are. Okay. As we work through the crash course, though, we're basically going to be writing a program that allows us to create like a shader toy like web page where we're basically rendering straight. All we have to do is make GLSL programs and just run them in the web browser. Okay, so I'm going to put this link here, the quick reference card. Out here on the GitHub, because we'll be using that quite frequently. All right, and then what else? Okay, so the next thing we want to do is, you know, now that we have this basic graphics example, right? We have a red screen. Now, it'd be nice if doing anything else in WebGL was this easy, but it isn't. So the first thing is not a WebGL thing, but it is a application issue. Okay, so there is a function called request animation frame. Okay, and what request animation frame does is allows us to tell the browser that, hey, we would like to draw again. Okay, and so we normally want to just run this endlessly because we're running a simulation. We just want to do this over and over and over again. Okay, so we normally just say, okay, request an animation frame, and we have to give it a callback. Okay, so what I'm going to do here is we're going to create a function called main loop that we're going to pass in a timestamp. Okay, and we'll just ask for time in seconds. Okay, and in this function, we're going to basically just call main loop again. Okay, so request animation frame, we want to go ahead and we're going to create what's called a lambda function. How many people are familiar with lambda functions? They're basically just functions you create on the spot. Okay, and because like in everything, so in JavaScript, a function is an object essentially. Okay, so we're going to pass in a this is what it looks like. Okay, we're going to pass in the time, which is in milliseconds, I believe. Okay, so, and basically we're just going to, this is what our function is going to look like. Now we need to convert the t from milliseconds into seconds, so we're going to divide it by 1,000. And then we're going to go ahead and call, we're going to call main loop again. However, this won't just work, okay? Well, actually it will. I'm thinking about the class. So at this point, we'll just spend a minute talking about, I guess, organization of your app. So we could just make this as just a bunch of functions, and then, you know, it's kind of like the procedural programming where you just have a bunch of functions and you call main, and then you just, your program is, but we were going to use a class. So let's just call our class, we'll call it app, and this will let you get a taste for what object-oriented programming looks like in Oops. Okay, there's a special way of formatting. Okay, so we're going to add a constructor. All right, and at this point we're going to say let app equals a new app. So that basically calls the constructor, and then we'll just go ahead and start the main loop. Okay, now this function over here. Oops. If I try to call main loop, we can't just, it's not going to know what the this pointer is essentially, because this function that we just passed to this lambda has its own this function. So we're just going to capture what this is, and so we'll say let self equal this, and now it kind of looks like Python code because we're using self dot, you know. So then we'll call self dot main loop. Okay. And then that's what it is. Let's modify this just a little bit. Let's create like an update function. And we'll say self.update. And then maybe we'll have like a draw call. All right. And so then we'll, after we've updated, then we'll just go ahead and draw. And in order to make sure that this works, let's just let's say our update. This is something I like to do because we're always doing things with time. So we'll say that self.t1 equals t seconds, and then self.t1 minus self.t0. I don't really do that anymore. Actually, dt. A lot of times we're going to know how much time has changed since the last time. Okay, so now what we're going to do is we'll just go ahead and do our gl.clearColor, but let's just go ahead and use the sine function, and we'll use whatever the current time is times. So let's fluctuate our red color, and then let's just go ahead and clear the depth buffer. Okay, so if all this works, if everything goes according to plan, we should be able to go back here and see what's up, and see a black screen.
You had an L after that last line.
Oh. There we go. So, so now we have, yeah, well, we should take the absolute value of the sine function. Otherwise, we're just saying. Okay. There we go. So now we have a quick example of how to write a little graphics application in JavaScript. So this is kind of like the bare basics, but we also have to learn about how to create shaders and how to pass in geometry and so on. So, but this is kind of like a good start to learning how to do graphics again. And you see it doesn't take very much code. Okay, and just to go ahead and we'll just go ahead and sync that up. I'll go ahead and send you guys a link to the GitHub page and the WordPress site and all that via an announcement with the Blackboard, so look for that email. And I should have the Crash course uploaded before Thursday. My goal is to have all this stuff uploaded before Thursday, so Thursday you can go in and take a look at the additional content. So if you have any questions, comments, feel free to just come chat with me.